Okay, I looked this over. This is a topic, again, it's not going to be in our test. It's sort of enrichment. I would give students a bonus point for doing this, but again, hopefully you're interested in your math career, and this is a useful topic. And also it could be used to do some of the examples you might have. And I should go back and say, the name of it is synthetic division. And something else you'll use in future courses, the remainder theorem. All right. Now, when we do division of polynomials, which we've just finished, it says another shortened way. Instead of long division, a shortened way to do it is to use synthetic division. But in order to do so, your divisor needs to be in this form. That is, this is just to the first power, and then some value here. This is a constant. So notice it's a negative of a constant. So when we set up our C, as you will see, it's the opposite sign of C because of this form here. So we just did that, and now we're going to show you synthetic division. So they're asking us to divide something, and we're going to divide by x plus 1. So our C term here is a plus 1, but because of the form that we have to use, it's the opposite of a plus 1. So what is the opposite of a plus 1? A negative 1. And that's where we get this from. I'm going to show you the process in the next slide. So we'll get to it here, and we're going to pass this over. Now, a helpful hint, whenever you're doing synthetic division, in fact, this is an absolute, you must put the dividend in descending order of variables. And if any are missing, you have to put a 0 value in that slot. And I'll show you in this next example. And I thought I had this written out here. But anyway, okay. So here they're saying, take this and divide it by this. And it's showing us this here, but I'm going to write it out as if this wasn't here. Okay. So the first thing I'm going to do is to figure out what I'm going to divide by here in a sense. So this is a negative 2. So according to our formula, x minus c, we have to take the opposite of whatever sign is there. So this is a negative 2. So our sign will be a 2. And I put the 2 right there. And they're using a little different way than I'm showing you, but very similar. Now, this is what we're going to divide into, but notice it's not in any kind of form. And we said to put them in descending order of the exponents. So my first term then would be 2x cubed, which I'm putting up here. Now, do I have an x squared term? No. So I'm putting my x squared term right here as 0x squared. Does that have any value? No, because 0 times anything is 0. And then my next term is x to the first that I'm putting right there. And then I have a 3. So I've put that in descending order with no missing degree of terms. Now, in synthetic division, after we identified our C, which is the opposite sign, I put that there. Then I have to write my coefficients only. I don't need the letters, just the coefficients. This is a 2. This is going to be a 0. This is going to be a -1. And this is going to be a 3. And that's where I get this line from. Now the basic rule is we take the 2, going to put another line here. We take the 2 directly down and we put it there. And we go 2 times 2 is 4. We put that right there. And now we add this up and we get a 4. And we go 2 times 4 is 8. We add that up and we get a 7. 2 times 8 is 16. We add that up and get I went down to the wrong number. It's 2 times 7 is 14. Add that up. That's better. And that gives us a 17. So, again, they kind of jammed me up for room here, but that's okay. So, basically, this is what they're showing. This is what we get. And be careful. So, once again, in summary of this, as we do it, we're almost finished. We put what we have to do in descending order. If it's missing a term, we put it in as a 0 value. We identify our constant. It's the opposite sign of what's there, so that becomes a +2. Put that there. And we start our synthetic division. We bring the first term down, that's our 2. Then 2 times 2 is 4. Add these up and get 4. 2 times 4 is 8. Add that up and get 7. 2 times 7 is 14. Add that up and get 17. So this is where we are. Now, the rule is, what was the original degree of your expression? Well, it was the 3rd degree. So what we do is we make this one 1 degree less, and we put x squared there. This is going to become x, and then this is x to the 0, which is 1, or just plain 7. And then this is our remainder, which will be over our original x minus 2. And that's what they have here. Okay? Now, if you did this by long division, you would end up with this as well. In a way, this is shorter, and many of you haven't seen this before, but with practice, and you will be needing this in your later courses. Now, the remainder theorem is given in function notation. So here they're giving you a polynomial that is going to be divided by this, and then the remainder then would be whatever value they give you here will be our remainder. and we'll see it worked out here. And let me do this one over here on the side for you. I guess I had that running, so you saw me set it up. So basically, here is our divisor, so to speak, and so it's the opposite of C. So remember, this is going to be what our C term is. And what will our C term be? Well, if this is what it was originally, our C term is going to be a 4. So this is what they're telling us. Our C term is 4. Now it would be divided by x minus 4, and now we're setting it up in synthetic division. So our negative 4 becomes a positive 4 up here. We're going to bring down our 1, and we go 4 times 1 is 4. Add this up, this gives us a 3. 4 times 3 is 12. Add that up, and that gives me a 10. 4 times 10 is 40. Add that up, and it gives me a 40. 4 times 40 is 160. Add that up, and it gives me a 161. Now, what do we have here? Well, this expression is to the 4th degree. So what we have to do, in a sense, is this answer would be x to the 3rd, 1 degree less. This is going to be 3x to the 2nd. This is going to be plus 10x. And then this is going to be plus 40. And then this is our remainder, which would be over x minus 4. And then we would put a plus there. But here they're asking for something special. They're saying the remainder theorem is when you have p of x, which we said that x is going to be a 4, that is going to be equal to, and again we're looking just for the remainder, 161. We don't write the bottom part. and that's the remainder theorem. And again, they didn't give us that much explanation here, but there's what we're looking for. We're looking for the remainder, and we find the remainder through synthetic division when our C term is 4. Okay? And in the expression, it would have been the opposite of C. So the opposite of -4 is a +4. Well, okay, again, this was extra and might be helpful, and it gets to be a little bit heavy.